All right, so this is section 3.7 on optimization. And I first of all want to say this, you guys. It sounds more complicated than it is. If you come up with the right equations when you're doing optimization, if you naturally just plug things in where they are supposed to be, and then you calculate the derivative, all of this stuff kind of falls right into place. So all of this first derivative, second derivative, plugging things in, and so on, don't make that harder. Don't make that harder than it is. And I will show you what I mean by that in just a minute. The first thing that you need to do is write up to 2 equations. I'm going to give you real world applications, and then your job is to figure out which one of all of your possibilities will either maximize or minimize what it is that you're trying to do. So you write a primary equation first, and your primary equation is always the equation that represents the max or the min that you are trying to find. So make sure that when you write your primary equation and you are writing your equation that has to do with maximizing or minimizing something. That's essential. You have to do that. I will show you what I mean by that in just a minute. If there's more than one variable, in other words, you're talking about 2 completely different numbers, if there's more than one variable, you're going to need to write a secondary equation. So if there's more than one variable, you will need a secondary equation. Once you write your secondary equation, you are going to solve for one of the variables in your secondary equation, and you are going to substitute it back into your primary equation. So then your primary equation will only have one variable in it. And then you find the derivative like you normally do. Remember when you find derivatives and you find critical numbers get you relative maximums, and they get you, relative minimums. Are you with me here? So you find your critical numbers, and you want to figure out whether or not it will maximize or minimize what you're trying to do. You're going to plug that number, that critical number, back into. Now I set up here that you're going to plug it back into your second derivative. Remember, second derivatives always give you if something is concave up or if it's concave down. If it's concave up, then you will know that you are minimizing what you need to do. Do you understand what I mean by that? Concave up means the graph does this. So it's going to have a minimum value. Concave up means the graph does this, which means it will maximize what's happening. So I want to say this, though. You can certainly do all of these problems with the second derivative if it's applicable. Sometimes finding the second derivative gets you just a number with no variable in it. Then it's not applicable. But I also want to mention that you don't have to do any of these problems with the second derivative. If you only find the first derivative, that will suffice. Remember when you found first derivatives, you would find out what's happening on the left side, what's happening on the right side, and if it's increasing on the left and then decreasing on the right, that meant that you had a maximum value. So the concavity test was just kind of like another way to check to see if it is in fact a relative maximum or a relative minimum. So you do not have to do the second derivative. So Larissa, that's why I kind of had a hard time answering that question, because you don't necessarily have to do the second derivative, okay? In fact, I have found that the second derivative just creates a little bit more work than you need to do. So, but that is how the book describes that you do it, so I wanted to make sure that I mentioned that. So, all right, do you guys have all of this down? I'm going to give you an example now. Where is my example? This is the example. Find 2 positive numbers. Now, you guys, I'm asking for 2 positive numbers. So if one of your critical numbers is negative, what are you going to do? You're going to ignore it. You don't have to deal with it. If it's a negative number, it's not an issue, which makes it nice. It gives you less work to do. Find 2 positive numbers that have a product of, what does that mean? Multiply. Product means you multiply. They have a product of 190 192 and the sum of the first and 3 times the second is a minimum.
No, but this is like so different than what we were just doing yesterday. Isn't it?
You're gonna do the first derivative, you're gonna do the second derivative, maybe the second derivative. Alright, you need to write me, like I said at the beginning, you need to write for me 2 equations, if you can. If this one requires you to have 2 variables, you need to write a second one. But the first one, the primary equation, had to be written in regards to what you're trying to maximize or minimize. What are we trying to, are we trying to maximize or minimize something right now? You're trying to minimize something. Since you are trying to minimize something, that has to be your primary equation. So your primary equation in this case has to be written in regards to the fact that the sum of the first and 3 times the second is a minimum. So what do you want to call the first number? X. Probably a good idea. So if I have x, the sum of the first and 3 times the second, sum means to add. So x plus 3 times the second, what do you want to call the second one?
Y.
Probably a good idea. Has to be a minimum. But I don't know what the minimum is, that's what we're trying to find. So I'm just going to say x plus 3y, that's equal to the sum. I'm going to call it sum for right now. We have 2 variables, right? And since we have 2 variables, that means that you need to use a secondary equation. So I'm going to write my secondary equation. Which brings me back to the stuff that they gave me at the beginning of the problem that says find 2 positive numbers that have a product of 192. How do I write that? xy, yeah, equals 192. That's your primary equation. And I mentioned the word substitution on the first page. So, solve for a variable here. Can we solve for y? Yeah. Can we solve for x? Can we solve for whatever one you want to. I'm going to solve for y. If I solve for y, what do I need to do? You divide by x. You divide by x, they cancel out. So y is equal to 192 divided by x. This so far, all doable, right? Yes.
You said that we use the secondary when we have 2 primaries. So what's our 2 primaries?
2 variables.
2 variables.
2 variables, yep.
Yeah.
So I have, in my primary equation, I have an x and a y. I have 2 different variables. And since I have 2 different variables, I know I need to come up with a second equation. Okay? Can I flip?
No.
So I have x plus 3y. That was my sum. And I also just found that y was equal to 192 divided by x. So now what I'm going to do is take this y value and I'm going to plug it in for that y value. So what I really have going on here is x plus 3 times y, which is 192 divided by x. This is my sum. Still talking about the sum. Are you okay with that? All I've done is just replace the y with what I'm saying y is. I gotta clean this up now. This is x plus, what is 3 times 192? That's what I got to. 576 over x. I know I'm gonna find the derivative, because that's what we do in here. I gotta rewrite this. So I'm gonna make this x plus 576x to the negative 1 power. Are you okay with that?
Mm-hmm.
I'm gonna move my sum over here too. Sum equals x plus 576x to the negative 1 power. Now I need to find the derivative. So the derivative of the sum derivative equals, what's the derivative of x is 1? Negative 576x to the
Negative 2.
negative 2 power.
How did you get, the third line?
Negative 1.
To the negative 1?
This line right here? X plus 576. So I took this, and all I did was I put the x up next to the 576. When I move it to the top, I have to change the power. Alright, we gotta find critical numbers. So when you find critical numbers, that means you need to figure out whether or not there are any values of x that make it undefined. So I'm gonna rewrite this as 1 minus 576 over x to the power of 2. I have a critical number right here. What is it?
0.
X equals 0. Why do I not have to consider this? It is not positive. The directions told me to find 2 positive numbers. That is not positive. So you don't need to worry about it. I'm going to cross it right off. Yes?
I don't get the next one.
You don't get the what one?
The fourth one.
1 minus. So I found the derivative of this. Negative 1 times 576 is negative 576. X, I have to subtract 1 from the power, so I have a negative 2. Now I had to get rid of this. I just had to make it positive, so I moved it to the bottom of the 576. So it stays a 1 minus 576 over x squared. Yes?
So we just had to find 2 positive numbers. Those are just your critical numbers.
Yes. Well, yeah. That's what they're going to end up being a critical number, because you're trying to find a number that will maximize the situation. Well, maximizing the situation means that they always happen at critical numbers. Highs and lows always happen at critical numbers.
So
All right, so we do not need to consider 0. Go ahead.
So if it's not like you said, it's a 2 positive. So since it's not x equals 0, isn't a positive that isn't one of the numbers. So will we still find 2 numbers or just 1?
No, you're going to find one number, and then you're going to go back to, remember over here, what we're doing here is finding x. What we're going to do is, once we find our x, we're going to go back to our substitution. This was what we came up with when we substituted, and we're going to figure out what y is by taking 192 and dividing it by our x value.
So we're really finding a point.
Yep, you're finding an x and a y. All right, so we have a critical number at 0. It's not going to count though because it's not positive. But now what we need to do is put that derivative, 1 minus 576 over x to the power of 2. We are going to put it equal to 0. We have to solve for x. So what I'm going to do, what'd you say? I'm going to take this minus 500, I'm just solving for x. I'm going to take this and I'm going to move it to the other side. So I have 1 is equal to 576 divided by x squared. The letter I want is on the bottom though, so I've always just said switch it with the other side. So x squared is going to be equal to 576. What's x then? 24. Yep. Take the square root of each side. X is equal to positive and negative 24. Why do I not have to consider both?
Negative.
One of them's negative. So 24 is the only thing that we need to consider.
Wait, what you do with the...
Once I got here.
Yeah.
well, the x squared is on the bottom. So whenever the variable you want is on the bottom, if you just switch these two,
Oh,
put the x squared where the 1 is, put the 1 where the x squared is,
okay.
then it just becomes x squared equals 576 divided by 1. Then you take the square root of it and square root of each side.
So you get 24. Now, I told you guys that you can go through and find the second derivative right now if you want to figure out whether or not it's concave up or if it's concave down. But I also said you don't have to do that. And I would probably suggest not even bothering to do that. I would suggest just working with your 24. You have more critical numbers than just 24. You have critical numbers at 0, negative 24, and 24. But you know what? Just work with this 24. Just check what is happening. What is happening from negative infinity to 24, and then what's happening between 24 and infinity. But it makes me a little bit nervous because if you say anything between negative infinity and 24, and you choose to pick 0, well, 0 was a critical number, and technically that kind of separates and creates its own little region to check. So my suggestion would be to, when you're doing this, check a number that's really close to 24. Give me a number really close to 24. Try 23. Try a value of 23. And then try something right after 24. 25. Try 23, try 25. What are you going to type into your calculator? Yeah, try this. Type this in. 1 minus 576 divided by x squared. Type that into your calculator. Make a table. Try 23 and 25. What happens at 23, you guys? Not concave. Is it a negative number?
Yes.
It's a negative number. So if it is a negative number, what does that mean? It's a first derivative. So that just meant that we had a decreasing slope, not that it was going to be, concave up or concave down. We just have a decreasing region. What happens at 25, you guys? Okay, we have a positive, which meant that it was a increasing region. Now, so that means to the left of 24, the graph is going down. To the right of 24, the graph is going up. What does it mean about 24? Minimum. Is that what we were trying to do? Were we trying to minimize what was happening in this problem? Was. So that means that x equals 24 is our minimum. So you guys, I just want to say this. We have done the first derivative test. We have checked, is it going to be a max or a min? Exactly the same thing you do when you are finding a relative max or min, which is all stuff that you should know how to do at this point. It's showing up on a test very, very soon. We know it's a minimum. All we have to do is figure out the y now. The y, what is the y? It is 192 divided by 4. It's divided by x. 192 divided by x. So it's 192 divided by 24. What do you get? You get 8.
Is that where your two numbers come from?
Yes. So one number, 24, plus 3 times the second number, so in other words, 3 times 8, is going to minimize my sum. But it happens that these numbers also, 24 times 8, also have a product of 192.
So what is 8?
So what is what?
So what is 8?
8 is the other number. Remember the problem said this. The problem said to find 2 positive numbers that have a product of 192. One of the numbers is 24. The other number is 8. Okay? That was unnecessary. You are very right.
doing this and we didn't do the whole like negative and